Welcome to our project. We are Mechanicus.
In our city, Leicester, the number of new builds has increased exponentially over the last decade, with the council pledging to build 1.5 new households in the next 5 years.
Our project aims to reduce the carbon footprint created by this massive undertaking,
while using mainly waste products such as plastic.
Our project is split into 5 main parts. New builds may progress housing to accommodate the ever-increasing population, but in reality they often come at an environmental cost.
Construction of masses of homes leads to land depletion, solid waste generation, gas and dust emissions, and noise pollution,
as well as the use of natural resources, particularly non-renewable resources such as fossil fuels for transportation, limestone to make cement, and petroleum-based products used in insulating and roofing materials.
All waste from these projects ends up accumulating in landfills, which are already filled to the brim.
Landfills produce masses of methane, contributing considerably to climate change. Like new builds, landfill leads to land depletion, causing a disruption of biodiversity due to habitat loss.
Toxic chemicals from decomposing waste can also seep into soil and waterways, harming ecosystems and urban populations' health.
New builds and landfill are both essential to modern-day cities, yet, over time, have detrimental effects to the environment. Our solution is to use the energy collected in waste occupying landfills in a process called pyrolysis to produce more eco-friendly bricks.
We propose to produce biochar bricks to reduce the carbon footprint of construction. To investigate the production of biochar, we experimented with pyrolysis on a smaller scale.
After pyrolyzing coffee into its 3 main components, we separated our biochar and measured its volume.
We then mixed the biochar with dry cement in a 3-to-1 ratio.
To test the functionality of our biochar bricks, we made a typical construction brick to act as our control. We used the same volume of sand as biochar and mixed this with the cement in the same ratio.
We added drops of water with the pipette to both mixtures, stirring continuously until they reached a consistency suitable for moulding.
The sand bricks needed 30 drops of water, whereas the biochar bricks required 75. Our experiment was therefore consistent with our research, indicating the increased absorption of biochar bricks.
Though we added the same volume of sand and biochar to both mixtures, the sand bricks weighed 25.24 grams more. This showed the lightweight quality of biochar bricks in comparison to normal bricks.
We interviewed a member of the local community about their opinion on plastic bricks. Do you think you would live in a house made out of plastic bricks?
Plastic bricks? I'm not sure. I mean, normal bricks are very strong. I'm not sure.
At first, the local constituents were unsure about our idea, but after we showed them our proposal, they were much more convinced.
Well, now I've listened to what you've got to say. I'm more open to the idea. I would love to see some buildings made out of plastic bricks, see what they look like. Thank you.
Thank you for your time.